1.
Alright, so this question is asking for the pH of benzenosulfonic acid C6H5SO3H when the concentration is 0.286 molar. So we know that the pKa is 0.7, so we just convert that to Ka, which will be 10 to the negative 0.7, which is equal to 0.1995. So now we know the Ka, so all we gotta do is just set up the equation, which will be C6H5SO3H plus H2O, which will be in equilibrium with H3 plus and C6H5SO3 minus. So now we just set up an ice table. We start with 0.286 moles of this, and we just ignore the water. We start up with 0 of this and 0 of this too, and then we know that there will be a certain change, and that will be the same amount of change over here, but it will be additive. And then we know this is going to be 0.286 minus x, this is going to be x, and this is going to be x. Now we know that products or reactants will equal Ka, so all we have to do is just set up that equation, and that will be x times x over 0.286 minus x equals 0.1995. So if we just simplify the equation a bit, we get the quadratic form x squared plus 0.1995 minus 0.057 equals 0. So now just to solve for x, all we have to do is solve the quadratic equation. So I just use my calculator, but there's actually a formula for it too. This is x is equal to minus b plus minus square root b squared plus minus 4ac, not plus, it's minus, divided by 2a. But I'll just use my calculator to find it, and there were two answers. The positive one was x equals 0.159, and the negative one doesn't make sense because the negative concentration is just doesn't make sense. So now we know that H3O plus is equal to 0.159 molar, and now just to find the pH, all we need to do is negative log of that concentration H3O plus, which is 0.159, and that is 0.799. Alright, so the part B asks for the pH when the salt is the basic salt and has a concentration of 0.1 molar. So I'm going to assume we start with this concentration. So I'm just going to set up the ice table, but before that I have to write down the equation. And so the equation is exactly the same. It's H3O plus C6H5SO3 minus. So but now the initial conditions have changed, and we have an initial concentration of 0.1 molar here, but this is still 0 molar and this is still 0.286. Now the change over here, we know it's going to be minus x over here, it's going to be plus x over here, plus x over here again. And so we have an end concentration of 0.286 minus x, and 0.1 plus x. So just what we did over here, we're just going to repeat the same thing. Products over reactants equals Ka, so 0.1995 equals x times 0.1 plus x divided by 0.286 minus x. So if we simplify this, we'll get the equation x squared plus 0.2995 x minus 0.057 equals 0. So again, we can use it but with the quadratic formula, or we can just use a calculator that can solve quadratic formulas. That's what I did. And again, the positive one is 0.132, and so this again, the H2O plus concentration, I can just plug this into negative log of H3O plus equals negative log of 0.132. That's our pH, and that will equal 0.879. We can see that the pH has increased from our 0.799 by adding the basic salt, and that's our final answer.